Hello everyone. Today we will discuss elementary operations or transformations based on matrix. So there are total 6 elementary operations. First we will discuss what are these 6 elementary operations. After that we will discuss where we will use it. Basically we use these all elementary operations for finding inverse of a matrix. So first of all we will discuss what are these. So 3 row elementary operations are there and 3 column elementary operations are there. Here I have written format. After that I will discuss one by one by using example proper value. So we will discuss first format. The first row elementary operation is we can interchange any row, any 2 rows means Ri interchanging Rj. Any 2 rows we can interchange but it will not affect the given matrix. Similarly, first column elementary operation, that is we can interchange any 2 columns means Ci interchanging Cj. We can write if we are taking I equals to 1 first column, if we are taking j equals to 2, so we can write it as C1 interchanging C2. Means in place of C1 we are writing C2, in place of C2 we will write C1. This is called interchanging value. Now second row elementary operation, that is the multiplication of the elements of any row by a non-zero number. Means for finding inverse we can multiply any scalar quantity in a row. So the pattern is Ri tends to Kri. Means if I am taking here k equals to 1, k equals to 2 I am taking, and I have taken here 2. So we can write it as R2 tends to 2R2. So this is second row elementary operation. Similarly, second column elementary operation, same pattern this is also, but in columns we are using the multiplication of the elements of any column by a non-zero number. So this is Ci tends to Kci, means we can write it as, if I am taking C3 and K I am taking here 3, so this is here 3C3. We can write like that for finding inverse. Third elementary row operation is the addition of the elements of any row, the corresponding elements of any other row multiplied by any non-zero number. Meaning is we can take one row and this row equals to same row plus scalar multiplication with the other row. Ri tends to Ri plus Krj. We will discuss examples also based on this. So similar elementary column operation, that is the addition of the elements of any column, the corresponding elements of any column multiplied by any non-zero number. Ci tends to Ci plus Kcj. Means we can take it like that C2 tends to C2 plus 2C3. This is I have given example. So these are total 6 elementary operations. Basically we use these 6 elementary operations for finding inverse of a matrix. Now one by one we will discuss these by using example so that it will be clear for you all, because this is very important. Because based on this, by using elementary operations we have to find out inverse, and based on this 1 4-mark question can come in your board exam. So this is important. So first row operation, that we have seen Ri interchanging Rj. So example I am taking for this, we can interchange any 2 rows. This is the meaning. So I am taking here a matrix, matrix A I am taking with the order 2 by 2, minus 1, 7, 2, 3. So here it is, if I am taking R1 interchanging R2. So matrix A will be here we can write 2, 3 minus 1, 7. We can take it like that. Why we are taking? For finding inverse of a matrix. Similarly, first column operation, that is Ci tends to interchanging Cj. We can interchange any two columns. Again, one more example I am taking. This is again of 2 by 2 I am taking 9, 2, 5 minus 10. I am taking here C1 interchanging C2. So A we are getting after that. So it is here 2 minus 10, 9, 5. Though this is first row elementary operation, this is first column elementary operation. I think it is clear for you all. Now second row elementary operation we will discuss, that is Ri tends to Kri, means we can multiply any scalar quantity with a row. So example I am giving for this. If I am taking A with the order 3 by 3, 2, 7, 9, 3, 4, 5, minus 1, 0, 2. I am taking here R3 tends to, one row I have taken, and I am going to multiply any scalar quantity with this row. R3 tends to, I am taking here 2R3. So R3, this is R3. So the resultant matrix will be here. Rest, we will write the same. 2, 7, 9, 3, 4, 5. R1 and R2 similar we will write. Now we will change only in R3. So in R3, first element is, here it is A31. This is in R3. So it is minus 1. So when we are applying it, so it will be minus 2. Similarly A32. This is 0. So when we are applying, it is 0. Then A33. This is 2. So when we are applying 2 into 2, that is 4. Means we are applying, we are multiplying with row 3 number 2. So that we are getting a matrix. Why we are doing all this? For finding inverse of a matrix. We will discuss it. Now second column elementary operation is Ci tends to Kci. Similar pattern it is. Means we can multiply any scalar quantity with a column. So taking a matrix here, 3, 4, 9, 2, 3, 1, 1, 5, 2. This is again of 3 by 3. What we are doing? We are taking here C2. C2 tends to minus 7 C2. Minus 7 is a scalar quantity K. So we are multiplying it. So the resultant A will be here 3, 2, 1. C1 and C2 will write as usual. 9, 1, 2. Just we have to change in C2 position because elementary operation we have applied in C2, column 2. So minus 7 into 4. So it is here, I am going to write it minus 7 into 4. Then minus 7 into 3. Minus 7 into 3. Then minus 7 into 5. So resultant I am getting here 3, 2, 1, 9, 1, 2. And here it is minus 28, minus 21, minus 35. So this is second elementary column operation. Now third elementary column operation we will discuss. Ri tends to Ri plus Krj. Ri and Ri. Here both similar rows, but here we are taking scalar multiplication of any other row. So we can take example for this. I am taking here matrix A. I am taking for this. This is again I am taking of 3 by 3. 1, 2, 3, 4, 5, 6, 2, 4, 6. What I am doing here? I am taking R3 tends to R3 minus 2 into R1. You can see the same operation I have used. I in place of I have applied 3. Again here I have applied 3. In place of K I have applied -2. And in place of J I have applied any other row that is not equals to I. So this elementary operation I am applying here. So we are getting here 1, 2, 3, then 4, 5, 6. It will change in R3. So it will be here. We will calculate one by one. This is a 3, 1 position, that is 2. So we have to use it. It is written here R3 tends to R3 minus 2 R1. So R3 is here. We will find out R3 after applying this operation. So R3 value we are getting 2. R3 value we are getting 2. And then minus 2 into, and R1 for this element 2 is 1. So into 1. So the value R3 we are getting here 2 minus 2, that is 0. So here we will write 0. Corresponding element we have to take. Secondly, A32. R3 second element is A32, that is 4. Again we will apply R3 tends to 4 minus 2 into R1. R1 for this 4 is 2. So 2. So again we are getting 0. Similarly, third A33, that is here 6. We are applying here R3 tends to R3 minus 2 into R1. R1 is here 3. For this 6, R1 is 3. So finally we are getting here 0. So we are getting here 0. So this is third elementary operation. So we will use these all 3 elementary operations in columns and 3 in rows for finding inverse. I think you all are getting it. How to use it. Now third elementary column operation we will discuss. That is Ci tends to Ci plus Kcj. Same pattern you can see. Just applying in column. So example I am taking here 1, 7, 9, 2, 3, 4, 5, 6, 7. 3 by 3 order. What I am taking, C1 tends to C1 plus 3 into C2. C1 1 I have taken. Then here also I have taken the same. J I have taken 2 and K I have taken here 3. So resultant matrix will be here. Again one by one we will find out. C1 we have to change. So rest columns we will write first. 2, 3, 4, 5, 6, 7. C2 and C3 we will write first because there will be no change in C2 and C3. Now we will change in C1 because elementary operation I have taken based on C1. So it is what? C1 plus 3 C2. C1 plus 3 into C2. C1 plus 3 into C2. So resultant we are getting for this C1 and position is A11 position. So 1 plus 6, that is 7. 7 we are getting. Then A21 7. So A21 again we will apply C1 plus 2 into C1 plus 3 into C2. So C1 plus 3 into C2 is here 3. So this is 7 plus 9. So value we are getting here 16. So it is here 16. So we are changing value. Now third place means here A31 place. So this is C1 plus 3 into C2. C1 plus 3 into C2. So 9 plus 12. So it is here 21. So this is the way to find values when we are applying elementary operations. column operation or row operation. Thank you.